Welcome back to Construction in Kenya. My name is Edward J. Makalo. This week we're going to be talking about the stages involved in the construction process. And you know, my number one rule of thumb is that you need to put together a team of professionals who have one goal in mind, and that is to deliver the project on time and of the quality that is required. So when it comes to building, there are two types of works that you need to put in mind. Number one is the substructure works. The substructure works are all the works that are involved below the ground level. Number two is the superstructure works. The superstructure works are all the works that happen above the ground level. When it comes to dealing with substructure works, the first step that you need to think about is excavating the vegetable topsoil that is usually about 150 millimeters. Once that is done, then setting out has to happen. And setting out process is generally a process that shows the general extent of the building. The architect also usually comes on board during the setting out process, and generally what he'll be doing is just to confirm that the column is in the right position, the boundary wall is in the right position, and generally everything that goes below the ground. The engineer comes on site. What he'll do is he'll recommend where the trial pits are going to be dug. And trial pits are important because the engineer is able to tell the nature of the soil and is able to design a foundation that is suitable for you. So once the engineer goes to site and realizes, let's say, one part of the land there is rock and the other part there is black cotton soil, he's able to recommend and design the proper design of the foundation that is required. Different grounds have what is called self-bearing capacity. Self-bearing capacity is what the engineer is going to use when designing the foundation footing for your building. So let's say if it's a strip foundation, he's able to tell the size that the strip foundation footing is going to be and also how it's going to be reinforced. Since the foundation is the heart of every building, it is therefore important that the trial pits are dug so that the engineer cannot under-design or over-design the foundation of the building. It is a fact that different grounds may need different types of foundations, and we will go through the different types of foundations in the next videos. But for now, if you do have any questions about substructure works, please let me know in the comments below and I will be able to follow up with them. Before we go ahead to superstructure works, there is one little joke that I thought about and I thought I would share with you. So what is the tallest building a man could ever build? A library, because it has so many stories. So when it comes to the superstructure works, this entails all the works that happen from the ground floor up to the roof. So it will include the ground floor, the slabs, the columns, the beams, the lintels, and the roofs. It's at this stage of superstructure where you'll see majority of the professionals coming together to ensure they deliver the project. The engineer will also come and pick some samples of the building materials, take to the lab, for example, sand, so he's going to test whether the quality of the materials are in check. When pouring concrete, you need to ensure that the concrete has been properly vibrated. Once it's properly vibrated, then it means that honeycombs will not form and the reinforcement bars will not be exposed to rust. After concrete is placed, the strength of concrete increases for a period of 7 days. In order to increase the strength of concrete, then we must cure it. Curing basically increases the strength of the concrete to about 50%. Water curing is a simple process and it can be done by building dams of soil around the slab. Once that is done, then you need to flood the dams of soil with water. In order for concrete to become stronger, it needs to be left to dry for about 21 days. Finally, when it comes to roofing, then roofing follows the architectural design. Let's say in this case, it's a flat roof. So the engineer is going to ask whether the flat roof is supposed to hold some weight, let's say a tank. So if it's yes, it's going to hold on a tank and some other weight, then the engineer is going to provide you with a design that is going to be able to cater for the weight. If the design of your roof is a pitched roof, then appropriate trusses are going to be put up and the roofing that has been recommended is going to be installed. That will be all for today. Please make sure to like, share, comment, and subscribe to Construction in Kenya with me, Edward J. Makalo.